Good morning and welcome back to Brodeur, all 8th grade math students. Hopefully you got back into the swing of things yesterday. So today we're going to talk about day 2 for week 4. So let's get things rolling. Let's see what today's question is. So today it says give 3 examples of a function, but also give 3 examples of a non-function. And what happens is we want to use all different types of representations. So that means we got to use ordered pairs, we got to use equations, tables, graphs, and also verbal representations. So let's go over to my whiteboard, and what I really want to do is I want to make sure not only do we talk about each representation, but I can kind of show you a lot of different examples, and that way you can feel as comfortable as possible. So let's get this show on the road. So right here, first thing we got to talk about is a function. So just a refresher, a function is where each input, usually we associate inputs with x, has only one output y. So I feel like the easiest thing to do first is to start with ordered pairs, just because ordered pairs are what a lot of people might feel comfortable with first. So the first thing is, when we start with ordered pairs, I'm going to place x values in here. So I'm going to place like a 0, a 1, a 2, a 3. Now notice what I did here. I only placed like 0 once. I didn't have 0 represented twice as an x. And that's because each x can only appear once up here, because each x should only have one output. So now I'm just going to go put in y values. So 0, we'll just say 0 goes to 1, maybe 1 goes to 5. Maybe if you want to throw in a negative number, that's fine. We'll say the x value of 2 goes to like -4. But now, some people might say, Mr. Brodeur, what happens if I decide to use the same y value as another one? Like, oh, wait a minute, 2 and 3, they have the same y value. Does that still make it a function? Yes, because 2 only appears once on here, and it only has one output of -4. Sure, 3 shares an output of -4, but 3 is its own input and only has strictly one output. So that is okay. So this would be an example of a function. You could also pick a different number and have all the y's be different numbers. That's fine. I'm just showing you what happens if you happen to choose the same y. Now, what would be a case where the ordered pairs are not a function? So that would be a situation where, let's say I'm writing down these numbers, 0, 1, but maybe instead of 2, I place another 1 right there, and then I place my 3 like I had before. This is an issue, potentially, because we have 2 x values that are exactly the same. And the moment this becomes not a function is where, let's say I put 5 here, but I put a 7 right there. That's game over. That's not a function, because now we're saying, wait a minute, each input x should just have one output, but clearly 1 doesn't just have one output, it has 2 different outputs, which creates that as not a function. Even if like 0 is 1 and 3 is -4, that's fine, but the moment that this 1 has 2 different outputs, which is kind of the definition of not a function, that means it's going to be not a function. So there's your examples for ordered pairs. Now let's take a look at a table. So going under function again, in order to do a table, it's kind of like doing ordered pairs just in table form. So I could literally take my ordered pairs that I have over here, 0, 1, 1, 5, 2, -4, 3, -4. And this would be a function. The reason why this would be a function right here is because clearly all my x's only appear once, and each x is just going to clearly one output. So that would be a function. Now, an equation. How could you make an equation be a function? Well, so far in 8th grade, all we've talked about is graphing linear equations. And we know a linear equation is y equals mx plus b. So if we have an equation that's set up as y equals mx plus b, we're going to be good to go. So I'm just going to put in a number for m. We'll just keep it maybe simple and put like a 1.
Mr. Brodeur, what is m?
M, oh, that's a good question. So m, if you remember, is just your slope. And then your y, sorry, not your y, your b is your y-intercept. And so in a second, that's going to come in handy when we talk about a graph scenario. So I'm going to just do 1x, let's do plus maybe 3, something like that. Right there, boom, you got a linear equation. That's going to be a function because it's in that form of mx plus b. Now, could you make a fraction if you wanted to for your slope? Yeah, that's fine. We just got to have it in a form that looks like this and we'll be good to go. Now, let's go down to the graph below and let's talk about a case where it might not be a function. Now, if you're curious, let's go off of this graph first. If you went to go graph, and let me use a different color right here. If you went to go graph y equals 1x plus 3, I'm going to go up here. That means I'm going to graph my little y-intercept first, that 3. Going to go on my y-axis. And then here, this slope right here is really 1 over 1. And so I'm going to go up 1 to the right 1. And I could keep going up 1 to the right 1. Or I could go down 1 to the left 1 and so on. And you would get a linear equation, which would be a function. Because if you remember, each x down here only has one point of the graph above it. Like here at 1 has just 1 point, 2, and so on. Now, how could you make this not a function? You could make this not a function by, let's say you drew a graph that looked like this right here. And some of you guys might remember seeing graphs like this back in Unit 2. You didn't learn how to graph them, but you might have remembered seeing these. And clearly, this would not be a function. The reason why is, let's go to this point right here at -1. If I go to -1 right here, when I go, and I'm going to use a different color, let's use red right here. I have not just 1 point above this x value of -1, I have 2 points. And that creates a situation where my x right here, my input, has more than one output. It kind of falls in this situation right here where you had 1 and 1, but it had 2 different outputs. Same thing right here. And so that would be not a function. Another quick way you could do this too is if you drew a vertical line straight up and down. Does that vertical line, and they call this the vertical line test, does that cross the graph more than once? And it does. So that also means not a function. So the last one we have not talked about is a verbal representation. So the last one I got here is you have an input. There is one copy of a book in the library. And they say the output is the book has been checked out by 5 different people. So what happens is you have this one book. I'm going to draw like a little cool book right here. Book. All right. So this one book, it's being checked out by 5 different people right here. Well, what's happening is this book is your one input, and it clearly has 5 different outputs. That's game over right there. That means you have not a function. And so in that case, that would be not a function, and that would be an example. In order to make that a function, a quick way you could do that is you could change that into where you have like 5 books, but they're only going to one person. So you have 5 copies of a book, but each book is just going to one person, and that would be a function. So those are just a lot of different representations you can do. So all in all, I hope this helps kind of clarify, helps you come up with some ideas on how to create your own function, not a function representations. But just let me know. Let your teachers know. If you got questions, send us emails. We'll be glad to answer. But until next time, Brodeur out. Peace.